Hi and welcome. In this video we are going to work through all the questions in the Mathematics GCSE Foundation tier paper of June 2019. So question 1 asks us to write the number 478 to the nearest hundred. Well, the hundred column is the 400, and if we are looking to round, then the number we need to be looking at is the 7, and we use the rule, is this 5 or above? If it is, we round up. If it's below 5, we round down. Well, a 7 is definitely 5 or above, so we need to round this to the number 500. And question 2 is write down a multiple of 8 that is between 40 and 60. Well, answering this will depend on your confidence in your multiplication tables. If you do know your 8 times table, then you will know that 8 times 6 equals 48 and 8 times 7 equals 56. So either of those two answers would be good. If you are not so sure, then you would have to count up in 8s until you get to one of the numbers that you are looking for, and again the same numbers would appear. Question 3, change 1.5 kilometers to meters. Well, we simply need to know that 1 kilometer equals 1,000 meters, so we start with 1.5 and we multiply that by 1,000. Now the simplest way to do that is to take the decimal point and move it 1, 2, 3 spaces and fill in the zeros, so we end up with 1,500 meters. In question 4 we are given a list of numbers and we are asked from this list to write down all the numbers that are powers of 3. So we are looking for 3 to the power 1 and 3 squared and 3 cubed, etc. So let's work out what these are. Well, 3 to the power 1 is just 3. That isn't in our list. 3 squared is 3 times 3. So that's 9. That does appear in our list. 3 cubed is 3 times 3 times 3, which equals 27. So again, that is in our list. Now 3 to the power 4, 3 times 3 times 3 times 3 is 81. So we've reached the end of our list. The two numbers that we need therefore are 9 and 27. Question 5 simply asks us to write 19% as a fraction. Well, the simplest way to write a percentage as a fraction is to simply put it over the number 100. 19% is 19 hundredths. The next step we would do would be look to simplify that, but as there is not a number that will divide exactly into both 19 or 100, we're not able to do so, so 19 hundredths is our answer. Question 6, work out 20% of 80. A couple of ways round of doing this, but what you might want to do is look at the fact that 80 is 100%, so if we divide that first by 100, we get 0.8. Here we have found 1%. To find 20%, we then take the 0.8 and we multiply it by 20 to get the answer 16. 20% of 80 is 16. Question 7 is telling us there are 4 types of counter in a bag. The table shows the number of each type of counter in the bag. We have a table and then the question. There are more green counters than red counters. How many more? So first of all, let's have a look at what's actually in the bag. Well, green counters, we have some green circles, 26 of them, and green squares, 7 of them. So our total number of green counters is 26 plus 7, 33. We also have some red counters in the bag. There are 16 circles and 11 square counters. 16 plus 11 is 27. So if we're being asked how many more green than red, it is 33 minus 27. The answer is 6. Question 8. Here is the gauge of a fuel tank of a car. The car holds 52 litres of fuel when the tank is full. The tank is 1/4 full of fuel. Work out how many more litres of fuel are needed to fill the tank. Well, first of all, If it holds 52 and it is a quarter full, the first thing we need to do is find out what is 1/4 of 52. So that is 52 divided by 4. Therefore, there are 13 litres of fuel in the tank at the moment. We need to know how many more litres are needed to fill the tank. Well, if it holds 52 at the moment and there are already 13 in there, then we need an extra 39 litres in order to fill it. Question 9. Simplify 4e plus 6f plus 7e minus f. So what we're being asked to do here is collect like terms. Let's have a look at the e's first. We have 4e plus 7e. 4 plus 7 is 11e. Now let's take a look at the f's. We have plus 6f minus 1f. 6 minus 1 is 5. So we have plus 5f. 11e plus 5f. Question 10. Bill has 400 counters in a bag. He gives 35 to Samina, 50 to Henry, 75 to Lucas, and we've been asked what fraction of the 400 counters is left in the bag. And let's be careful, we need to give the fraction in its simplest form. So first of all then, how many has he given away? Well, he's given away 35 plus 50 plus 75. So if we add those up together, we get 12, 30, 40, 15, 160 that he's given away. So to find out how many there are left in the bag, 400 minus 160 means that there are 240 counters still in the bag. So as a fraction, that is 240 out of the original 400. Here we have our fraction, but again we have to give it in its simplest form, so we need to simplify this. Many ways you can do this. The most obvious start would seem to be divide by 10. So if we divide them top and bottom by 10, we get 24 over 40. If we look at these again, what can we divide them both by? Well, they will certainly both divide by 4. That would give us 6 over 10. And we can now divide by 2. So that will give us 3 over 5. And as simple as we can make it is 3/5. Question 11, part A. The table shows the cost of sending a parcel by either express or by rapid service. And Brendan has to send 12 parcels. It's telling us it will be cheaper to send the parcels by express than by rapid, and wants to know how much cheaper. Well, if we first of all look at the price of rapid, that will be 12 times £35.38. So the total price there would be £424.56. On the other hand, we have the express, which we are told is cheaper. Well, that will be 12 times £15.25. So the total cost there is £183. And if we subtract one from the other, the difference is £241.56. And then we move on to part B. Luke wants to send 21 parcels by the express service. He does the calculation 20 times 15 equals 300 to estimate the cost. Our job is to explain why Luke's calculation shows the actual cost will be more than 300. To answer this, you'll need to look at how he has rounded the figures. He wants to send 21 parcels. For his estimation, he has rounded down to 20. The actual price per parcel is £15.25. Again, he's rounded down to 15. So a good phrase to use when answering this would probably to say that he is underestimating. He has underestimated the number of parcels and also the price. Therefore, both in reality are slightly higher than his estimation, so the overall cost will be higher. Question 12. Ali, Ben and Kathy share an amount of money in the ratio 6 to 9 to 10. And we're asked what fraction of the money does Ben get? Well, The ratio you are given is in the order of the names of the people. So Ben is the centre here, so he gets 9 parts of this ratio. Now to express it as a fraction, if we add up the total parts of the ratio, 6 plus 9 plus 10, we have 25 parts in the ratio, and Ben is getting 9 parts out of 25. Again, we would look to simplify this, but in fact 9 and 10 will not divide by the same number, so 9/25 is the final answer. Question 13. The first term of a sequence is 24. The term-to-term rule of this sequence is add 8. Now part A, Josie says no number in this sequence is in the 5 times table, and we're asked to give an example to show that Josie is wrong. Well, let's start with the first number in the sequence then. We know that is 24. We are then being asked to add 8 each time, so the next term would be 32. Let's try a couple more, see whether this works. Plus 8, the next number in the sequence is 40. Number 40 is in the 5 times table, therefore that is the example that we can give, 40. Part B, is 85 a number in this sequence? And it says give a reason for your answer. Well, the reason is the first number in the sequence is an even number, and if we continue to add 8, in other words another even number, then every number in this sequence is going to be even. 85 is an odd number, so it cannot be in the sequence. So your answer needs to be all the numbers in the sequence are even. 85 is not, so it cannot be there. Question 14. Find the value of, and we have a sum there. It says give your answer as a decimal and write out all the figures on your calculator display. So you're going to have to use a calculator to do this, and it very much depends on the make and model that you've got. One of the more common models has a button where you have a square, a line and a square, and usually the top square is filled in. Now if you press that button, you will find that a fraction type symbol appears on the actual screen. You are then able to type in the top line of the sum, and then by using the large round button in the center and pressing the down button, you then find you are able to input the bottom line. As I say, this does vary from calculator to calculator. If you do that correctly, you will end up with a fraction. And in this case, the fraction says 877 over 354. The trick here is to press the button which has a double arrow saying S to D. It will change the surd or the fraction into a decimal, and the number you will have on your screen is 2.477401113. Again, you need to play around with the calculator you are using and familiarise yourself with the use of that particular model. Question 15, part A. You can use this rule to work out the total hire charges in pounds for hiring a 3D printer for a number of weeks. And we are told that the hire charge is the number of weeks times 70 plus 50. So in fact what you are being charged here is a £50 deposit and then £70 per week. Mia wants to hire a 3D printer for 4 weeks, so when we put the 4 into this rule, the number of weeks is 4, and we are told it is number of weeks times 70 plus 50. So using BIDMAS here, we have to do the multiplication before we do the addition. So 4 times 70 is 280 plus 50, therefore your total cost is £330. Let's have a look at part B, where Zahir is hiring a 3D printer and his total hire charge is 680, and we've been asked for how many weeks does he hire the printer. There are a couple of ways you could do this. First of all, you could use algebra. So using the rule at the top, the number of weeks, let's call that x, and we know it is x times 70, therefore that is 70x plus 50, in this case equals £680. So we're looking at the rules totaling 680. Therefore 70x equals 680 minus 50. I've moved the 50 to the other side of the equation. So 70x equals 630. That means x equals 630 divided by 70, which equals 9. Therefore, Zahir has hired the printer for 9 weeks. There is another way you could look at this. If we have a look at the total charge of £680, we know the £50 is a deposit. So actually we can just take off the deposit, and that leaves us with 630. So 630 is in fact the total hire amount without the deposit. If we divide that by 70, which is the amount per week, again we get 9 weeks. Question 16 here is a rectangle, so we have a rectangle with the dimensions. The 6-sided shape below is made from 2 of these rectangles, so 2 rectangles put together. Work out the perimeter of the 6-sided shape. Well, let's fill in the figures that we already know. So the top of a rectangle is 4, so we have 4 centimeters here and also over here. This one has simply been laid on its side, so this is also 4. We know the long side of a rectangle is 6, so 6 would be here, and also at the top and bottom of the one that is on its side. So we have most of the perimeter already worked out, except for this small section here. Well, if we take a look at the fact that the side of the rectangle is 6, and we know that the one on its side here only reaches 4, then this section here is 4, so the little section must be 2. So all we need to do now is add up the sides. So we have 6 plus 4 plus 2 plus 6 plus 4 plus 6 plus 4. And if we add them all together, we get 32 centimeters. Question 17. The accurate scale diagram shows a telephone mast and a box. The box has a real width of 1.5 meters, and we want an estimate for the real height in meters of the telephone mast. Well, there are a couple of different ways you can do this, and please be aware that the scale that I am using on a computer screen here is not going to be the same as for a paper exam. However, I'm going to start by measuring the width of the box on my screen, and I have it here that the box looks as though it is 19 millimeters. I then want to have a look at the height of the mast. So if I move my ruler across to the mast here and measure the height of it, we are looking at 113 millimeters. So that is the mast. Now what I'm going to do is take the 113 and I'm going to divide it by 19. The answer is going to be 5.94. Well, we're looking for an estimate, so I'm going to call it 6. That means that the mast is roughly 6 times higher than the width of the box. So if I take the width of the box, which is 1.5 meters, and I multiply that by 6, I'm going to get the answer 9, which is 9 meters. Question 18. The table shows information about the numbers of points scored by 30 students in a quiz. And part A says find the modal number of points. Well, the modal simply means the most common number of points. And if we look down the table, it's telling us that 4 students scored no points, 3 students scored 1 point, 7 students scored 2 points. And looking down the right-hand column, the most common score was 2, because 7 students scored 2 points. So the modal number of points is 2. Now, to work out for part B the total number of points scored, we are simply multiplying. So we have 4 students scored no points, therefore 0 times 4 is 0. 3 students scored 1 point, and we go down the table. 3 times 1 is 3, 2 times 7 is 14, 3 times 5 is 15, 4 times 6 is 24, and 5 times 5 is 25. And if we add them all together, we have a total of 81. Question 19, we are asked to make x the subject of the formula. Let's just write the formula out again. Y equals 2x plus 4. So to make x the subject, we need to get everything else to the other side, and we're going to use BIDMAS backwards. So the first thing that we would move would be the 4. It's a plus 4 where it is. We move it to the other side, it becomes a minus 4. So we now have y minus 4 equals 2x. The next thing we are going to do is to move the 2. At the moment it's multiplied by the x, so if we move it to the other side, it's going to become a divide by. So there we have it. Y minus 4 over 2 equals x. If you wish, you can write this the other way around. X is the subject, y minus 4 over 2. Question 20. The diagram shows a square, ABDE, and an equilateral triangle, BCD. We need to work out the size of the angle that is marked here, which is EBC. Well, clearly the angle is split into two parts, and the way forward here is to work out the size of both of those parts and then add them together. So let's have a look at DBC, the angle inside the triangle. It's an equilateral triangle, which means all sides are equal and all angles are equal. The angles inside the triangle add up to 180. So if we divide that by 3, we get the angle 60 degrees. So that's the first part of our answer. The next part is to look at angle EBD. Well, this is a square, so that we know the corners of a square are all a right angle. And if you take a diagonal straight across from opposite corners of the square, we are dividing it exactly in half, which leaves us with an angle of 90 and then 45 and 45. So the other part of our angle is 45 degrees. If we add 45 and 60, the answer we get is 105 degrees. Question 21. Liz goes on holiday to South Africa. She wants to change £850 into South African rands, and she wants to get as many 200 rand notes as possible. We've then got the exchange rate, and we're asked to work out the greatest number of 200 rand notes that she can get for £850. Well, the first thing we need to do here is work out how many rand she is going to get. So the exchange rate is £1 equals 18.53 rands. So let's multiply £850 times 18.53. And if we do that, we get the answer 15,750.5 rand. Now, that's the total in rands. Now that is the total amount of rands that Liz is going to get. We need to know how many 200 rand notes we can get out of that. So we're going to divide that by 200. And if we do that, we get the answer of 78.75. That is effectively how many 200 rand notes she can get. Obviously you can't have 0.75 of a note, therefore the answer will be 78. Okay, question 22. In October, Sally drove 560 miles in her car. The car is travelling at 34.5 miles for each gallon of petrol used. Then we have some figures here that petrol costs £1.08 a litre and a conversion rate of 1 gallon to 4.55 litres, and we have to work out the cost of the petrol. So let's start by looking at the distance. We have travelled 560 miles. And we know that we are getting 34.5 miles for each gallon. So if we divide the distance by 34.5, that will tell us how many gallons used, and rounding to 2 decimal places, we get 16.23 gallons. Now the price for petrol is being given in litres, so we need to convert this into litres. So we have a conversion rate, 1 gallon equals 4.55 litres, so 16.23 gallons. We need to multiply by 4.55 and we get 73.85 litres, and again I am rounding to 2 decimal places. We are now looking at the price. Well, if we have 73.85 litres and it is costing us £1.08, that's the multiplication that we need to do, and we end up with a total price of £79.57. Question 23. Costco sells packets of mints to shop owners. On Monday, 3 shop owners buy mints, and each shop owner buys small packets, medium packets and large packets. We then have some figures telling us about Alan, Beryl and Charlie and how many packs they buy each. We need to work out the total number of medium packets that they buy altogether. So let's have a look at this. Alan first. We are told that Alan buys 400 packets of mints, so we have a total of 400. 32% are small packets, so that will be 400 times 32 over 100. That means small packets he buys 128. Large packets 40%, so that will be 400 times 40 over 100, and that means that the large packets are 160. If we add those together, we will get 288. Take that away, because these are the small and large packets, take that away from 400 and that must leave you with the number of medium packets. So medium is 112. That is our first total. Beryl is buying 500 packs. 3/10 are small, so that's 3 over 10 times 500, and that works out at 150 small packs. 1/10 are large packets, so that's 1/10 times 500, and that's 50 packs. Again, add them together is 200. That is the total number of small and large. We need the medium. She bought 500 altogether, so let's take away the total of the small and the large. That means she must have bought 300 medium. Now we're looking at Charlie. Charlie buys 150 small packets of mints, and we're given a ratio of small to medium, and we are told that the ratio of small to medium is 3 to 4. Now we know that Charlie buys 150 small packs, so if we look at the ratio here on the left hand side, from a ratio of 3 to 4, this has been multiplied by 50. With a ratio, we need to do the same on the other side and multiply that by 50. So 4 times 50 is 200 medium packs. We don't need to know how many large packs Charlie is buying, because our question is the total number of medium. We have 112 from Alan, we have 300 from Beryl, and we have 200 from Charlie. So we just need to add those 3 figures up, and we're going to get 612 medium packets. 3, 2, 1. Question 24. We have a Venn diagram, and we are given some numerical information about the numbers within the diagram. So don't forget, the first line with the symbol here means the universe. So that is every number that is in the diagram. A then tells us how many numbers are within the circle A, and B tells us which numbers are in the circle B. Now first of all, we need to be careful to make sure that we are looking out for any numbers that appear in both A and B. and straight away we can see that the number 9 appears in both. So number 9 is going to go in the center here where the two circles intersect. Number 6 is also in both, so again that's going to go into the center, and that is all. We can then put the other numbers in here. So number 1, 5 and 8 belong inside A, so that's 1 and 5 and 8. The number 2 belongs inside the set B. What we now need to do is include all the numbers that are not in either of the two circles. So 1 we already have in, 2 we have in, 3 we do not, 4 we do not, we have already used 5 and 6, 7 is not in either of the two circles, 8 is, and 9 is. So we have now completed the Venn diagram. Let's move on to part B. It says find the probability that a random number chosen from the universe, that means any number within the diagram, find the probability that it is in the set A intercept B. Well, that is the center here. So in other words, the only two numbers that it could be are 6 and 9. So we have a choice of two numbers. How many numbers are there altogether in the universe? There are 9 numbers in the universe. So the probability that it is in the set A intercept B is 2 out of 9. 3, 2, 1. Question 25 tells us that Katie invests 200,000 in a savings account for 4 years. The account pays a compound interest rate at a rate of 1.5% per annum. Calculate the total amount of interest Katie will get at the end of 4 years. There are 2 or 3 variations on how you might do this, but let's have a look at a couple of them. First of all, we can start with the amount that is in the bank account at the beginning of year 1. Now, don't forget, 1.5% as a multiple is 0.015. So to work out the interest at the end of the first year, we are going to multiply 200,000 by 0.015, and for that we get the amount of £3,000. Now if we add that onto the 200,000, it means at the end of year 1 in the bank account Katie has 203,000. So at the beginning of year 2, that's where she starts, with 203,000. Again, the interest rate is the same, so we're going to multiply by 0.015. This time the interest rate works out at £3,045. So at the end of year 2, let's label these year 2, she has £206,045. So year 3, that is where we start, 206,045, multiplied again by the same interest rate. This time the interest earned is £3,090.68, rounding to the nearest penny. So at the end of this year she has £209,135.68. This is the number we're going to put in at the beginning of year 4. So that's where we start. That was year 3. We are now on year 4. We are multiplying once again by the same interest rate. This time the interest is £3,137.03. So the total amount and the answer to our question is £212,272.71. Another way that you might go around this, if you are familiar with using a scientific calculator, is to put the amount in, the 200,000, and then multiply that by 1.015 to the power of 4. So that 1.015 is 101.5%, and the power of 4 to represent the number of years, and you will come out with exactly the same answer. Question 26. The table shows information about the heights of 80 plants, and we're asked to find the class interval that contains the median. Well, the class intervals are the different lines here. We have a total, as we're already told, of 80 plants. Therefore, to find the median, we put them in order. Well, they pretty much already are for us in a table like this. So we want the one that's in the middle. And of course, the way to find the median is to use the total number plus 1 divided by 2. So that's 81 over 2 equals 40.5. So we are looking effectively at where the 40th and 41st plant are. So from the top, we add up. The top group has 7 plants. Add that to 13, we get 20. Add that to 14, we get 34. Add that to 12, we get 46. So by here, we are at 46 plants. We have passed the 40th and 41st. Therefore, they are within this group here, which means that the interval that contains those plants is this interval here, and this is exactly what you write in the answer. Now for part B of this question, we're asked to draw a frequency polygon for the information on the table that we've just seen. Now the way we do this is to look at each of the class intervals, and let's just take a look down the page at this, because the class intervals are here. So we have 10 to 20, 20 to 30, 30 to 40. Now in order to draw the diagram, we need to use the midpoints. So we need to figure out what the midpoint of each of these class intervals is. And it's quite simple. The midpoint of 10 to 20 is 15. 20 to 30 is 25. So we use the midpoint all the way down here. Therefore, when we plot our graph, the height, which is the x-axis, we are going to use these points up to 65 here, and up the y-axis we are going to put the frequency. So let's translate that back onto the graph, and we can see the numbers are already put in there for us. We said the first class interval was from 10 to 20, so the midpoint is 15. The frequency for that particular class was 7, so our first cross is going to be at 7:15. Just there. Our next one, the class interval was 20 to 30, the midpoint was 25, so up from 25 we are going to put our cross at the frequency of 13. And so we go along. 35, it was 14, so 35, we go to 14, put our cross there. At 45, it was 12, so 10, 11, 12 is there. 50 to 60, midpoint 55, and the frequency was 16, so that's going to be our next. And finally we have the class interval 60 to 70, the midpoint was 65, and the number was 18, so that's going to go there. Once we have those, we simply get a ruler and a pen, and we join the dots with straight lines. So our frequency polygon is going to look like that. Question 27, Sean has drawn a time series graph to show the numbers in thousands of visitors to a fun park. And we're asked to write down 2 things that are wrong or could be misleading. There are certainly more than 2 options here, and you can choose 2 from any of the following. First of all, the scale at the side starts at 6,000 rather than starting at 0, which could lead to a misleading looking graph. Also, the scale is not regular. It goes up in 500s each time it goes up a square until the last square where it suddenly jumps up 1,000. So again, this leads to misleading figures. The years are along the bottom, but actually the numbers 2, 3, 4 do not necessarily mean anything. We could assume that they are quarters, but if they are, where is the first quarter? So no real information there. The line itself is irregular, it is drawn by hand. We should really have used a ruler and joined the points up with straight lines. Again, choose any two from a list. Question 28, we have a diagram showing a hexagon. The hexagon has one line of symmetry. Now if we look at the detail we have here, it tells us that the line BC is the same as AF, and that is confirmed in the question. Also, EF and CD are equal, so we know that the line of symmetry actually goes down the centre of the shape. Now, we are told that angle BCD, that is this angle here, is twice the angle CDE. It seems as though this information is useful to us, so let's call CDE angle X, because by doing so, if BCD is 2 times, then we can label that 2x. Now, because we have a line of symmetry, we have the angles down the right hand side, they are going to be exactly the same as the angles down the left hand side. So AFE is going to be 2x and DEF is going to be x. Let's next look at the total of the interior angles of a hexagon, because that's something we're going to need here. To find the interior angles of any polygon, we take the number of sides. Hexagon has 6. We take away 2, so we end up with 4, and we multiply that by 180. So the total of the angles inside this hexagon is 720 degrees. Let's use that to work out the value of x. Don't forget, we're being asked in this question to work out the size of angle AFE, which is 2x. So let's first of all find x. So we know that all these internal angles add up to 720. So we have 117 plus 117, which is 234, plus 2, 4, 5, 6x. So 6x, that's adding all the other 4 angles together, plus the 234 at the top, all adds together to be 720. That means that 6x equals 720 minus 234, so 6x equals 486. That means that x is 486 divided by 6, therefore x is equal to 81 degrees. So if we know that x is 81 degrees, we are looking for the angle AFE, which is 2x, therefore it's 81 times 2. So angle AFE is 162 degrees. Question 29, Jeremy has to cover 3 tanks completely with paint. Each tank is in the shape of a cylinder with a top and a bottom. The tank has a diameter of 1.6 and a height of 1.8. We have a diagram here confirming. Jeremy has 7 tins of paint, and each tin of paint covers 5 meters squared. And we're asked whether or not Jeremy has got enough paint to completely cover the 3 tanks. And we must show how we get our answer. Well, the first thing we need to do is work out the total surface area of one cylinder. So what we have here is a circle on top, a circle on bottom, and a curved side. Let's look at the area of the circle first. Okay, so we have circle area, which is the top, and we're going to use pi r squared. Now, if the diameter is 1.6, then the radius is half that. The radius is 0.8. So we have pi times 0.8 squared. This is the job for the calculator, and to 2 decimal places we end up with 2.01 meters squared. Let's remember there's a top and a bottom, so let's multiply that by 2 and we will get 4.02 meters squared. So that is the top and the bottom. Now we need to look at the area of the curved sides of the cylinder, which we know is going to be the height times its width, its length, and to find its length, well, that is the same as the circumference of the circle. The sides wrap around the circumference. So we need to find the circumference of the circle. So this time we are going to use 2 pi r. 2 times pi times 0.8. And we get 5.03 meters. So that is the circumference of the circle. To find the area of the side, we need to multiply that by 1.8. And if we do so, we get 9.05 meters squared. So that is the side of the cylinder. To work out the total area, we're going to add the side area to the top and bottom. So we have 9.05 plus 4.02. That gives us 7,031, 13.07 meters squared. That is the surface area of one cylinder. Don't forget Jeremy has to cover 3, so we're now looking at 13.07 times 3, which gives us 39.21 meters squared. That is the area in total that we need to cover. Let's have a look at the amount of paint he's got. Well, he's got 7 tins, and each tin of paint covers 5 meters. So the paint is simply 7 times 5 is 35 meters squared. He needs enough for 39, so the answer is no, he does not have enough paint. Finally, question 30, and we are asked to solve the simultaneous equations. Now, in order to do this, we need to eliminate either x or y in order that we can find the value of one of them. There are a couple of ways to do this. Let's try this by calling this equation 1 and this equation 2. What I'm going to do, I'm going to multiply equation 1 by 3. I do this so that my x's become 9 for both equations. So we now have 9x minus 12y equals 33. So I have multiplied each term in the first equation by 3. The reason I've done that, let's call this 3. If I now look at 2 and 3, they both have 9x. So let's take one away from the other. Let's do formula 3, take away 2. So 9x minus 9x disappears. Minus 12y minus 2y is minus 14y equals 33 take away 5 is 28. So minus 14y equals 28. If we then move this around, y equals 28 divided by minus 14. Therefore y equals, well, 28 divided by 14 is 2. A positive divided by a minus is a minus. Therefore y equals minus 2. That's the first part of our answer, y equals minus 2. Now we need to put the value of y into one of these equations to work out the value of x. So substitute into, let's use formula 1. So we are left with 3x minus 4 times minus 2. Let's just put brackets around that to be sure, equals 11. So here we've done minus 2 in place of y. We now have 3x minus 4 times minus 2 is minus 8 equals 11. Now don't forget, 2 minuses are a plus, so that actually says 3x plus 8 equals 11. We can now say that 3x equals 11, move the 8 across, is minus 8. So 3x equals 3. Therefore, x equals 1. And that is the second part of the answer.